So I'm really happy to be back with you today. I'm going to talk a little bit about what we see in the marketplace in cloud computing. So one level above the Oracle Public Cloud that Tyler just mentioned. We're very excited by the Oracle Public Cloud, yet it is really one of many clouds that are really out there. And in fact, I want to share with you what we see our customers are doing in the area of cloud computing. What clouds are they choosing and why? And then what is our response to that? You know, I was in the back of the room and I noticed that it's really hard to see this data. So I apologize, and I believe these presentations will all be available in PDF form off of the Cloud Expo website shortly, if not sooner. So, okay, the headline I'm sure you can read. Private cloud adoption is increasing. Is that a surprise to anybody in the room? Probably not. Last year when I was here in front of this crowd, we shared with you a survey that we ran through the IOUG, that's the Independent Oracle Users Group, which are made up of Oracle customers, so larger organizations typically, maybe down into the medium size of the market, but generally speaking towards the larger side. You can see the results of that 2010 survey on the left. In 2011, so just 2 months ago, we reran the survey to see what the change was, and no surprise there. Today, 37% of our customers say they already have a private cloud, either in full production at scale, in limited use, or in pilot. This represents a 28% increase over last year. So now 37% of our customers today already have a private cloud. What about public clouds? Well, some of this data is what is encouraging us to make the move towards the Oracle Public Cloud, for example. We see public cloud adoption also increasing. Last year, it was only about 14% of our customers were using public clouds. Today, it's 21%. So that's a 50% increase in just 12 months. I don't think this surprises anybody in the room. I wonder if anybody is surprised by the fact that there is more adoption of private clouds rather than public clouds. I don't know. But I think that this is a fairly well-accepted trend that we hear from Gartner and IDC as well. At least in our customer base, there does seem to be a slightly greater preference for private clouds, although you can see here that the growth rate of public clouds is greater. Now here comes my real eye test. I apologize. The takeaway, though, here is that we see many cloud use cases, and some of these are fairly intuitive and obvious, I think, to most people, and others are not so obvious. So what we looked at was private clouds and public clouds, and you can barely see the text there, but what this says is, you know, we found that most often cloud computing is used for new applications. A little bit more often than extensions to existing applications. So typically when there's a new application project, that's the trigger point for a new cloud or adoption of the cloud, both public and private. But we see both. The second takeaway is clouds are used quite often for development and test, as well as production. So development and test, I think most people recognize that as a very ideal use case for cloud computing because it makes use of shared hardware and testing resources a lot more efficiently if you can use a cloud model to access resources in a self-service mode and return them to the pool when you no longer need them. But we found that both public and private clouds are used for both dev and test as well as production workloads. We find that enterprise apps are actually more often put into the cloud than departmental apps. I don't know if that's a surprise. Some people think that departments are more likely to take their departmental app and use cloud computing for that. Actually, it turns out that enterprise class apps are also quite often in the cloud. The fourth one says more often used by employees rather than by customers, partners, or suppliers. That's fairly intuitive and obvious. The two on the bottom are kind of interesting. Both stable and dynamic workloads. So another popular use case for cloud is I've got a very dynamic workload. I have a spiky or fluctuating pattern. I have high growth rate, unpredictable growth. And so I'm going to use cloud computing to take advantage of that and make use of that efficiently. But we found that more often both stable as well as dynamic workloads are put into the cloud. We found that cloud bursting is actually still quite rare. Only 5% of our customers said they were doing cloud bursting. This is the mode where I've got an application and the steady state workload I'm going to run in my private cloud or on-prem, but when I see a spike in the workload, let's say around the holiday season or the end of quarter, then I'm going to burst out and use the public cloud for that. That's actually quite rare. We only see it 5% of the time. Lastly, long-lived apps more often than temporary apps. So and again, a typical cloud use case, I've got a temporary app that's I don't plan to be in existence for more than a year. Why don't I use the cloud for that? Well, sure, that's a very good use case, but also long-lived apps. Sometimes I'm going to have an app that survives indefinitely, and I'm still going to use the cloud for that. So this is an interesting set of findings. You can see here that there's a wide variety of use cases for cloud computing. Wrong way. Let's try this way. Okay, so the top private cloud applications. Again, we see some changes year over year. The top application category tends to be homegrown applications, so custom applications. See a big jump there in departmental applications from 13% last year to 27% this year. And then a variety of others, financial and accounting apps, human resources apps, email, collaboration, communication, customer service, and finally CRM and sales and marketing applications. So quite a variety of apps. You can see that we rank ordered them in accordance to the latest survey from 2011. So we asked the same question about public clouds, and this is what we found as well. This year, the most popular application category to put into the public cloud space seems to be email and collaboration and communication. The second most popular is sales and marketing, so CRM. The third most popular is HR and benefits. But if you look carefully, you can see that there's adoption across the board, isn't there? It's not like there's an obvious first application that I'm going to use cloud computing for, neither public nor private. There's actually quite a wide range of things that I'm using the cloud for. And this is kind of what we've seen over and over again. One more finding before I get to a little bit different topic area. Once again, we found that the platform layer, so-called platform as a service, with things like application server as a service, database as a service, identity as a service, these are clearly more popular than infrastructure, including storage, compute, and dev and test. I put in that category because dev and test is primarily the use of virtual machines for development and testing. So we see this to be true not only in the private cloud setting, which is a little more obvious, but it's also true amongst our customers in the public cloud setting, which I thought was fascinating because I didn't expect that finding myself. So PaaS, more often than not, outpacing infrastructure. And we'll come back and explore some reasons why that might be true in a little bit. This is a slide that I used last year, and I hope you bear with me because I still think it's quite relevant and still true. We see an evolution going on in the area of cloud computing. It's really an evolution of what's been going on in the industry for a decade. It's data center transformation. It's the never-ending journey towards becoming more efficient, more cost-effective, more agile, more be able to support innovation, etc. And the evolution that we've seen looks a little like this. In the private cloud setting, right, most companies are starting out with data centers that they already have and applications of all kinds running in these data centers. And they tend to be running in fixed, static, physical environments. They tend to be quite mixed. There might be a little Oracle in there. There might be some Microsoft in there. There might be some open source in there these days. A wide variety of things, all heterogeneous, running on siloed infrastructure. One of the problems with this, of course, is that it's not very efficient, right? If any of these apps is a highly fluctuating workload, a spiky workload, the hardware needs to be sized to support that spike. There's no way to share across applications. So the architecture of running in silos is highly inefficient. Each silo is sized for peak workload. There's inherent excess capacity in this architecture. Most orgs are moving from this siloed model to a consolidated model. Right? Consolidation has been a trend that's been happening for years now, and we see it at two different levels. We see consolidation happening at the infrastructure level, leveraging, obviously increasing hardware horsepower, and also technologies like virtualization to share that massive piece of hardware across multiple apps while maintaining, good isolation amongst them. So this notion of sharing is a concept that's part of cloud computing, and consolidation is really related to cloud. So we see that happening at the infrastructure level using technologies like virtualization. We also see consolidation occurring at higher levels of the stack, and this is not really talked about too often, but we actually see it more often at the platform level. Customers are deciding that I'm going to consolidate not using VMs, but using a standardized database or a standardized Java application server for all my apps, regardless of whether they are departmental or enterprise, whether or not they are, they have very heavy availability or performance requirements, or whether they're just mundane garden variety applications. I'm going to put all my apps onto a standardized database, a standardized middle tier. And you can imagine that this is what drives that next level of enhanced efficiency. Because if you're just leveraging virtual machines, you're still going to have tons of complexity. You're still going to have that mix of stuff on top. You've done nothing to simplify your administrative workload. You have admins for Oracle with admins for Microsoft and admins for everything else. There's no change to that environment if you're just doing virtualization at the VM level. If, however, you're able to take the next step and standardize and move to a standard, shared, and elastically scalable platform, suddenly you're able to take out some of that heterogeneity and minimize that extra cost. That's what we see going on. Consolidation is clearly, a mainstream trend in the road towards cloud today. The next step is, of course, adding some of that agility that people speak about when we talk about cloud computing. So we're talking about adding self-service access for end users so they can provision themselves, manage themselves, monitor themselves, they can scale up and scale down within certain quota limits or constraints. But this is really what's adding the agility factor or the nimbleness factor, enabling end users to do things for themselves where they couldn't before. And associated with that are policy-based scaling, automatic scaling in accordance to rules, also metering and chargeback so you can tell how much of the shared resource each tenant or each service owner is consuming so that you can typically charge back or bill for that amount of service. The next trend in cloud computing is adding these features. In the public cloud space, something similar has been going on. There are many service providers out there. Some of them are telco operators. Some of them are hosters. Some of them are ISVs. All these are morphing into these dynamic pay-as-you-go models that some people call public clouds. And of course, this has been happening. This is a significant trend in the marketplace, especially on the application side. There's hundreds of apps out there. They're wildly popular. Oracle has a number of them ourselves. One of the problems, though, is that these clouds, these public clouds, tend to be specialized. They tend to be isolated. It's very difficult to change your mind once you start using one of these. How do you actually extract your data and change clouds, for example? Very difficult to do in the current state. However, of course, where the world is going is to this notion of a hybrid model where there's both public and private, where it's really easy to move your applications and workloads from one public cloud to on-prem or to another public cloud to sort of change providers. And this is a model that I think is very attractive to the industry. It relies on standards, which are still in process and are still a little immature right now. Vendors like Oracle are taking part in the standards establishment process. Once these standards are established, the technology needs to be implemented, and then you'll be able to really take advantage of this really fungible cloud model where you can run anything, anywhere, and move it around quite easily. This is the evolution that we see happening, right? I'm going to try to walk through some of this in a little more detail. So, consolidation. We believe that consolidation is a mainstream trend. It's a predecessor, or at least a step on the road to cloud. It's one type of cloud, and I talked about different types of consolidation. So, consolidation can be done at two different levels, as I said before. You can consolidate onto a standard, shared, and elastically scalable platform. That might be database, it might be middle tier, what have you. Or you can ignore that, ignore the standardization part, and just consolidate onto shared hardware using virtualization, for example, right? This is the basic trade-off here. I want to point out a couple of things about the technology for a moment. Virtualization, right, a wildly popular technology for sharing hardware and maintaining good isolation between applications. Although it's not the only thing out there, virtualization is a way to take one large physical resource and divide it up into smaller virtual resources. There's another capability that's complementary to that. It's also been around for a decade or more. It's called clustering, right? Clustering is making multiple physical resources look like one so that applications don't have to know which specific node they're running on. You know, both of these work in conjunction with each other to deliver this sharing that's critical to cloud and this elasticity that's also critical to cloud. So I think a lot of people think about virtualization only as associated with cloud computing. You know, we feel like, yes, it's a critical enabler and a very important technology, but clustering is equally important. When you talk about virtualization, let's double-click there. It turns out that there's actually multiple ways to do virtualization, right? Most often, people are thinking about bare metal x86 hypervisors, right? Things like Oracle VM for x86 or VMware, right? These are technologies that run on top of x86 processors or server hardware, and they're very, very efficient. Turns out there's other forms of virtualization out there, right? There's actually other processor types like Spark, and there's bare metal hypervisors for that, like what we call Oracle VM for Spark, also called logical domains. There's also container technology, right, which is running on top of an OS, but running inside of individual containers on top of that. And there's also something called dynamic domains supported in our high-end machines, which is complete electrical isolation from one domain to another. It's maybe the most extreme form of security and isolation. But my point in showing you this slide is that we see clouds being built out of all these different models. And it's not just about x86 hypervisors and using VMware or Oracle VM to do that. What about clustering? Well, clustering is, again, something that can happen at multiple levels of the stack. It can happen at the storage tier, at the server tier, hardware. It can also be at the database or middle tier. This is a very hard to read slide, but my point in saying this is that you need this clustering, the idea of making multiple physical machines look like one to the workloads that use them. You need this at all levels of the stack. Oracle has these engineered systems. You may have heard a little bit about them. Exadata, which is a specialized, purpose-built machine specifically for database. Exalogic, which is ideal for Java and middle-tier workloads. And the newest member is something called the T4 supercluster, which is built out of Spark chips instead of x86. All these are what we call engineered systems. They are engineered to work together in a superior manner. Typically, it's based on performance. They're significantly better, not 10% or 20% better, more like 10 or 20 times better than anything else out there. And the result of that is that they're much more efficient for mixed workloads. So if you're consolidating mixed workloads, so moving on to this shared architecture that people talk about for clouds, these are ideal because you can actually put more and more services on a given hardware. So I think that a lot of people think that cloud computing is only associated with commodity computers and layers of abstraction. So why do I care what the underlying hardware is? Cloud just sort of obscures that away from me, does it not? And to some extent, that's true. Cloud does abstract away the underlying hardware. But somebody cares, right? The service provider cares, whether that's your own IT department as an internal service provider, or whether it's a public cloud service provider. Somebody cares about how efficiently that cloud is delivered to you, and therefore, there's actually a connection between these vertically integrated components that Oracle offers, in the context of cloud computing. They're actually relevant for cloud computing. I'm not going to make this an Oracle pitch, so I'm going to keep going here. I wanted to show you some examples, right? Here are 3 banks. They all happen to be banks. Credit Suisse, Commonwealth Bank of Australia, Deutsche Bank. All 3 have begun the roadmap to cloud through consolidation at the platform level, right? And they're being driven initially by the goal of saving money, no kidding, but they're also motivated to become more agile, become more nimble and to shorten the time to market for deployment of new applications. You can see Credit Suisse actually has different clouds. They have a Java cloud based on WebLogic, a database cloud based on Oracle Database, and they also have an infrastructure cloud that just uses raw compute servers and virtualization. CBA in the middle uses Oracle Database, initially running on third-party hardware, but in their second phase, they've taken Exadata, and so they're taking the next stage of that evolution, migrating towards Exadata to become even more efficient. And Deutsche Bank has been doing this stuff with databases for a while as well. Credit Suisse is quite advanced. They've been doing cloud for about 7 years. They have modeled their own self-service interface for end users. You can see that CBA has also been doing it for about 4 years. They've got an advanced metering and chargeback model in place, so they know exactly how much of this shared resource is being consumed by each app, and they use that to allocate costs or show costs at least back to the lines of business. 3 examples of customers doing what I just said, getting started by consolidation at the platform level. I don't want to make it sound like that's the only thing that's out there. There are other clouds. There's also infrastructure clouds. In fact, Oracle, this example here is Oracle itself with a private infrastructure cloud for dev and test. Obviously, Oracle is a big developer shop. We have a lot of developers, right? And we build lots of different products. We find that it makes sense to have a shared dev and test environment across all these different development teams, right? And there's a self-service portal on the front end. Developers sign in, they submit jobs, it gets prioritized and queued. It runs on a farm of servers in the background, and the results are returned a few hours or days later. I don't know how long the tests are. But this is a wildly popular internal service that Oracle offers. Again, another eye chart, but previously, the process for provisioning IT resources for our developers took a matter of weeks. It took many people, many weeks to get test resources available to the developer. Today, it's basically self-service. There's nobody involved. I think there's, 3,000 or 4,000 physical servers in this cluster. It's managed by, I believe, 4 people. So that speaks to the level of automation, the level of standardization, the level of self-service that our own internal cloud offers. Again, we were driven initially by the desire to save money. Otherwise, every lab would have to have all the hardware it needed for those peak loads that happen right before you launch a new product. By sharing, we're able to take a lot of that cost out. But ultimately, the value proposition here was not around cost savings. It was around time to market, right? It was about how fast can you give a developer access to the machine that they need. So 2 examples, some customers using consolidation at the private PaaS level, and Oracle using dev and test as an initial use case at the infrastructure level. Let's move on, because I think there are some people out there who want to take the next step beyond basic consolidation. They want to actually add self-service. Well, about a month ago at Open World, we announced Oracle Enterprise Manager 12c, which is a product that we're really proud of. It's been in development for, I don't know how long, I want to say 2 years about. It's the only solution out there that can enable you to manage the full cloud lifecycle, right? Starting from planning your consolidation or your initial capacity, setting up that cloud, configuring that cloud, building the apps to run on that cloud, packaging those, testing those, deploying those in a self-service manner, monitoring and managing and scaling up and scaling down as needed, measuring how much of the shared resource you're consuming so that you can meter it and see how much you're going to get charged for that. And then finally, optimizing, patching, et cetera. That whole life cycle we can do with one product. Not only that, we can do it for the entire Oracle stack, right? EM is not just a database tool. It can manage the entire stack all the way down to the servers and storage, up through the database, up through the middle tier, up through applications. It can even manage what end users are doing and seeing. It can manage the end user experience. If you're really good at managing one level of the stack, let's say you're really, really good at managing the virtualization layer, right? That's fantastic, but you have no hope to manage the end user experience, to understand what the SLAs that you need to achieve are from the end user perspective. You have no ability to diagnose problems. If there's a problem somewhere in that stack, if you're managing just the virtual container and you have no idea what's running inside of that container, how can you manage the end user experience? How can you diagnose problems? So we think that this top to bottom management is critical. And then the last thing that EM is really good at is enabling IT to manage the IT stack in a manner that's relevant to the business. We call it business-driven application management. And the best example of that is, like when a business user says, hey, I've been trying to run this long-running transaction in my application. It's stuck. I don't know where it is, And then they call up IT and say, hey, what's wrong? And then IT's answer to that question is, where's my transaction? IT says, the system's been fully available for the last, 30 days, running at 99.9% availability. That's their answer, right? But I'm just trying to point out that the answer that IT provides is mismatched to the problem that the end user business is asking. And so by the fact that Oracle owns its own applications, in addition to the full stack underneath, we're able to enable IT to better answer these questions that the business has. So EM 12c, that was a little bit of a commercial for that, but we're very proud of this product. For customers who want to take the next step in the journey to cloud by adding self-service to their consolidated environment, this is the right product that will do that out of the box. Okay, let's jump to public clouds, right? Public clouds are out there, certainly. I think Tyler said this, and I think not a well-known fact, but it turns out that a lot of the world's clouds, whether they're private or public, are actually already powered by Oracle. This particular slide talks about public clouds, specifically SaaS clouds like Salesforce, WorkStream, Reba. These clouds are actually, powered by Oracle underneath. So we're pretty proud of that. Here's another example, a customer example out there. And this kind of gets to that partner model that Tyler was talking about as well. This is one of our partners. It's actually a telco operator based in Japan called SoftBank. You may have heard of them, right? They're a telco operator. They've taken Exadata and Exalogic, which is our database machine and our middle tier machine, and are using it to power their public platform as a service offering that they call the White Cloud. That's their brand for it, the White Cloud. They're actually taking our database and middle tier and making it available to Japanese customers on a pay-as-you-go hourly basis. So an example of where we're happy to take our components and our architecture and share it with other service providers who may want to replicate it and deliver their own service to their own customers. Pretty interesting example. So here's another example. So what about customers who don't want to run on Oracle's cloud? Maybe they can use SoftBank if you're in Japan, but what about Amazon? That's a real popular one, right? And we've been working with partners like Amazon to enable them to run Oracle, right? There's a part of Amazon EC2 that actually supports Oracle VM. That's our virtualization technology. By virtue of that, the whole Oracle stack is fully supported on Amazon EC2. So a customer can take their Oracle database or their Oracle middle tier or application and run it on EC2, and we'll fully support that, certify that. They've got license portability from their own existing license. They can actually leverage that and get credit for it on EC2. So another example of running on someone else's cloud but running Oracle in that cloud. Another example, a little different again, Oracle On Demand. Right? Oracle has been in the cloud business for over a decade. On Demand is where we have a number of tremendous offerings that enable us to give customers what they want. And we find that customers want a lot of different things. In some cases, they want a fully isolated private cloud that's hosted and managed by Oracle. We'll do that. Sometimes they want to run it on their own premise. I want to run the Oracle application in my own data center, but I don't want to manage it. I would rather have Oracle On Demand manage it. Oracle will do that. That's called the at-customer model. We'll also manage it at partners as well. So this idea here is it gives customers a lot of trade-offs in terms of whether they own a license, whether they do hosting, whether they do management, et cetera. So we've been doing this for a number of years. It gives us a lot of tremendous experience in terms of our new offering, which is the public cloud. This is that public cloud that Tyler just mentioned. I won't go into it other than to say we're very excited by it, right? It's we believe, yet another compelling offering that we'll have in the marketplace. It's fully self-service, it's fully integrated, it's fully enterprise class. It's at the application level. You can see a number of applications there today, but that'll grow over time. There's a total of 7 categories of Fusion apps, not just CRM and HCM, but also financials, project management, supply chain management, procurement, etc. Oracle has one of the largest application portfolios in the industry, and all the Fusion applications run on standards-based middleware and standard-based database. So all of these apps you will see made available through the Oracle Public Cloud. At the platform level, obviously we're going to start with database and middle tier and Java naturally, but there's going to be more platform offerings as well, including some of the ones that Tyler mentioned. So we're very excited by this. Fully standards-based, enables you to, take your existing Java applications or your existing Oracle applications and move it from your in-house operation into the public cloud, or back and forth. You can also, let's say, do development and test in the Oracle Public Cloud, and then you can decide to deploy, let's say, initially there. But once you start to grow and scale, maybe you want to move it back in-house. That's not going to be a problem. You'll be able to do that with full, portability. One of the key benefits of what we're offering is this choice, because we don't see everybody doing the same thing. We see different people wanting to do different things, so we're all about this choice. So I hope I've given you some flavor for what we mean by, there are many clouds out there, and there are many choices that we're trying to offer the market. Oracle's sort of offerings for the cloud space are many. Another eye chart, apologize. But think about it this way, the 3 blocks on the left are our products that we offer enterprise customers to build private clouds. We offer applications, we offer PaaS or middle tier, and we offer infrastructure to help companies build private clouds. Those are all products on the left. We also offer Enterprise Manager there as well. The 2 things on the right, there's Oracle On Demand, which is a type of public cloud that we're offering, and there's also the new Oracle Public Cloud, which is that self-service subscription model that we mentioned as well. So you see here that we're trying to offer customers breadth, because we don't see that customers are doing one thing or the other. They're doing some kind of a mix. And that's the thesis of this talk today. Our goals here are to provide customers with many choices to enable whatever they're trying to do. The choice of private cloud, the choice of public clouds, delivering complete and integrated solutions at all levels of the cloud stack, not just the application tier, not just a bunch of virtualization software or a bunch of database software. We're delivering that whole stack, including apps, platform, and infrastructure. And then to enable customers to adopt the cloud at whatever rate of speed makes sense to their business, at whatever pace makes sense. Some people may want to simply do consolidation to save money. Other people may want to go further and add self-service, right, to enable that agility. Some people may want to shed everything that's in-house and just move entirely to the public cloud at some point. All these are going to be, at different rates of speed, and Oracle is really about enabling customers to do whatever they need. So I wanted to thank you very much for your attention today, and I think that was my last slide. So thank you so much.
Thank you.
Okay.